Okay, all right, well, welcome everybody. My name's John Lakos. I work at Bloomberg. I've been there for now almost 20 years, and I've been doing the same thing for about 20 years, which is working on large-scale C++ software design at a company that does a lot of large-scale C++ software design. So it's a good fit. What I'm going to talk to you about is a little different than perhaps you might be used to, because I'm not going to talk about the state of the working paper with modules, because that still is changing, and it's part of C++ 20, but people are still working on it and getting it just so, and the tooling and such is quite an issue. What I'm going to talk about is how we would use a modules feature, in other words, what it means to you as an everyday person. And it's going to be a while before modules are actually in use. But that doesn't mean that we can't start thinking about designing with them, because I've been designing with modules for 30 years. And so modules are a tool that help us to do our jobs better, but that doesn't mean we can't do our jobs today, because if we had to wait till today, when modules are out to do our jobs, we wouldn't be doing anything until now, and that's silly. So we're going to talk about stuff, how to use it, and so on. So C++ modules, that's the talk for today. Here's my copyright notice, because I have to do that. Here's an abstract, but you're already here, so don't worry about this. This is for the viewers on the at home. We're going to talk about what we're going to talk about. And I always start out with large-scale C++ has many dimensions. It involves logical and physical design. We should know that by now. We need to be able to isolate the functionality into fine-grained physical components. We need to be able to explain what our functionality is, and we will be doing that in terms of English contracts. And then the language itself, C++, lacks a higher level of ways to describe software, both logically and physically, that are coherent. So we have the notion of a translation unit. We would like something. We'd like something that we can use at a higher level of abstraction. And modules eventually may get us there. So the purpose of this talk is I want to review what I'm going to call component-based design. And component-based design is thinking about things at a higher level than a class. Modules at a higher level of abstraction than a class. So we're going to talk about component properties, implied dependency, basically the stuff that I've talked about forever, since 1996. But just to bring you up to speed, I literally have a deadline for my next book, which is coming out this year. I swear, I absolutely swear that it's coming out this year. I know because my deadline is Friday. I worked all the way here. I worked till 6 in the morning, and I'm here talking. I'm going to go have dinner, then I'm going to work all night, then I'm going to get on a train, and then a plane, and then a very long plane ride, and then I have to turn it in. So that's how sure I am that it's going to be done. So really, not kidding. It's going to be done. It will be out. I have a promise from my publisher that it'll be out this year. That's why they're killing me. So anyway, this talk that I'm about to give right now, the book is almost 1,000 pages. I'm going to give you the entire book right now in less than an hour. So it's no problem. It's all good. All good. So we're going to review these physical design things. Here we go. That's the first part. By the way, this talk is 4 parts, but I have time for only the first 2. The good news is the second 2 parts don't exist yet, because they're what we're working on to get modules to be even more expressive and more powerful. So I'm not going to really tell you all about the other 2 parts until they happen, but I'll give you a good idea of what we're looking for. So anyway, what we're looking at here, this slide, I'm not going to tell you when I wrote this slide, but I wrote it a long time ago. This is really representing a module. It has a logical component and a physical component. In fact, I call it a component. So logical for classes and functions, physical for files and libraries. I have these rectangles that represent physical things, and I have these either capsules or oval-shaped things where I represent logical things. And the idea is that we have units that are both logically and physically coherent. And if that has some intuitive meaning to you, that's great. Hopefully it will. There are some much more precise ways of saying that, but intuitively, the logical nature of the thing is encapsulated in some physical entity and isn't distributed throughout the ether. That's really what it means. So here I have this collection of physical entities. which heretofore we called components, and ideally might be called modules, and they consist of logical content, as you can see. And in the old module way, which consisted of a .h and a .cpp and possibly a standalone test driver to exercise your code, and guess what? New modules will look just like that, most likely. So anyway, this is what we have. We have an implementation file. We have a header file. Nothing is different about modules. They also have these things. And a test driver, and by the way, modules need to be tested. They don't solve that problem. In case anybody thought modules don't need to be, they do. Components and modules are the fundamental units of design, not classes, because you're building things that need to be assembled, and you don't assemble classes. You put the classes in the modules and you assemble the modules. So anyway, so what is a module, or what is a component? It's not just a .h.cpp pair. There are additional properties. Now, one of the interesting things is originally modules were a way of making things run faster, and it kind of like didn't seem to be as important that they had certain architectural properties. So a little over 2 years ago, I actually wrote a paper, which we're going to see a little bit later, that said, very short, it's like 3 pages in ASCII. And it's just like, whatever modules do, I don't care, but they have to satisfy these business requirements or I won't use them, period. And so that's that paper. We'll see that later. Anyway, there are some properties that modules have to have, and there's some properties that components have, and there are 4 of them. And the first one is that the .cpp file includes its header file as the first substantive line of code. That's been a requirement for C++ and C design for me forever. And there's a very good reason for it. Does anybody know why we do that? Why do we include the header file as the first line of code? Of the component, of specifically my .h file. I'm including it in my .cpp file. Yes? Okay, so you need to include the header somewhere, but why does it have to be the first line? Why the first line? Why don't I include standard? Yes?
To make the header self-dependent.
To make the header compile in isolation. Yes. You avoid include order dependencies by including your header first. It means that my header has to compile without any other headers. So if you take nothing else away from this talk, please from now on, always include your own .h first. Just do that for me. That alone is worth the price of admission. All right. Even if the CPP file is empty, at least you'll have some place before your clients find out that it does or doesn't compile. All right. The second one is all logical constructs having external linkage defined in a .cpp file are declared in the corresponding .h file. All right. Before we go further, what do I mean by defined and declared? What's the difference? What about internal versus external linkage? What does that mean? Ooh, okay. So fortunately, we can talk about that. So every definition is a declaration. I hate that, but apparently it's so. So for our purposes, a declaration is going to introduce a name into a scope. That's what we're going to mean for our purposes. Apparently, a declaration can introduce something else into a scope, but I don't care. The standard has some very interesting corners that as I said, it just makes life difficult. This thing that you just appeared, is that a declaration or a definition? What do you think? How many people think it's a declaration? Okay, how many people think it's a definition? How many think it's both? Okay, the answer is it's both. Okay. This is a test. What is this? Is it a declaration, a definition, or both? What's this? Declaration, definition, or both? What's this? What's this? What's this? What's this? Do you notice a pattern? Do you see it? Like, I could try to explain this, or I could do it by example. Turns out there's no way to explain it. It's by example. But you get it. What's this? This is a trick question. This is an interview question. It's a declaration only. Now, in certain platforms, it'll zero it out sometimes, maybe, whatever. It's a declaration only. What's this? No, I created an object. It exists. I can take its address. It's a definition. What's this? It's a definition only. Now, I was told by Chandler Carruth that this is a redeclaration and a definition, and I told him, all right, but it's really a definition only. Really, because that's my definition of definition. Okay? It's not self-declaring. Do you see what I mean? It's that kind of definition that doesn't declare itself. That's why it's a definition only, even though it's a redeclaration because the standard says so. Okay. All right. So, int A. That has external linkage. What do I mean by external linkage? I mean it's visible outside this translation unit. Do you see why this stuff is important for modules? Do you see? It's like we have to learn this stuff. Modules are going to make our lives really hard because we're going to have to get really smart about these things and know whether something is visible outside of the translation unit and things like that. That's what modules do. That's what components do. All right, so this has external linkage. It means that I can use it in another translation unit. What about this thing? Can I use it in another translation unit? No. We have Andre here, so you can check me. Destroy me on this. No, he's here to destroy me, not to learn. He told me so. All right, so what's this? Is it a declaration or a definition? Okay, does it have internal or external linkage? External linkage, right? I can call that from somewhere else. All I have to do is declare it somewhere else, and then I can call it, right? Is anybody confused by this? Don't worry about the idea that you might think it's inline or something like that. I mean, this is a definition, and therefore, I can call it from somewhere else. Okay. What about this? External or internal? Okay, what about this? External. It used to be treated kind of funny before it was standardized. This is external linkage. Okay, what about this? Internal. Okay, what about this? Okay, this? This? Good. This? Good. Okay, that's a declaration. This is a definition. Okay, namespace. Class foo. What?
Kind of.
It's internal. This is a namespace. It's an unnamed namespace. Right? Please? Okay, how about static int? No, there's no name. How about this static int d underscore s? All right. What about, this doesn't really have anything. I'm just saying it's kind of externalish, but it doesn't really have anything. No linkage. All right, so class foo in this named namespace. Static, what?
You spelled wrong.
What?
You should check your spelling.
What did I spell wrong?
Namespace with capital M and the PS.
Oh, that's a bug. Extra credit. Yeah, thank you. I have to fix this for CPPCon. That's good, I have to remember that. All right, so this is external linkage. This has external linkage. That has external linkage. What about this? Doesn't compile, why? So that's a declaration, that's a definition, that's a declaration, that's a definition, and that's a definition, and these guys are fighting because they're defining the same thing. If I take that out, then this is internal linkage. If I take that out, this doesn't compile again. Anyway, that's a tour of some stuff. Now that we know what I was talking about, all constructs having external or dual bindage declared in a .h file if defined at all are defined within the component. Wait a minute, I forgot to tell you about this guy. I have to tell you what it means here. So what I'm saying is, if something is visible, potentially visible outside this translation unit, then I want to declare it in the header so human beings can know visibly that it's not just an ABI collision, it's actually here. So it doesn't matter whether it's public, protected, or private, it's that it can be seen outside the translation unit. If it can be seen, it needs to be part of the physical interface that human beings can see. That's what this means. All logical constructs having external linkage that can be seen outside the translation unit or module defined in the CPP file must be declared in the corresponding .h file. They can be declared public or private, they can be free operators, whatever they are, but they have to be declared. Now, this one is saying all constructs having external or dual bindage. What is bindage? Bindage is something different. Bindage is something I made up. What are examples of bindage? Can anybody think of what I might mean? Bindage has to do with tools. If the compiler is doing the binding a name to its use, then we say it has internal bindage. The compiler is doing it. If something is being handled by the linker, then we say it has external bindage because the linker is doing it. Now here's the tricky question. Can anybody think of something that has dual bindage, meaning the compiler might deal with it or the linker might deal with it? What do you think? Templates, that's one. Can anybody think of any other construct? Inline functions, excellent. Those are the only two that I know of. Templates and inline functions, they behave the same way. What's interesting about them is their source code, the bodies, exist in the header file. So the compiler has a crack at inlining them. So templates that are not marked inline are still fair game to be inline. You realize this, right? Okay, so that's fine. And if the compiler chooses not to inline them, then the linker gets a shot. So that's dual bindage. Okay, sorry. So the example here is all constructs having external or dual bindage. In other words, if the linker can get involved, if it's possible for the linker to get involved, then we must not have a local declaration. We must include its header. Does that make sense? What we're saying is if there's a possibility that the compiler, my compiler, will never see the definition of that thing, then it is not okay to declare it locally. It is just not okay. You must pound include. Now, if I know that later on my compiler will get a whack at this thing, then it's okay to forward declare. So if you have a class declaration, and there are reasons not to forward declare classes, but it's not evil like forward declaring a function. So keep the difference in mind. Okay, and the last one is a component's functionality is accessed via pound include. This idea is somewhat redundant to the others, but what it's saying is, in order for me to discover the physical dependencies of my system, my collection of modules, I want to look at the pound include or alternatively the import directives of my module. And I don't want to have to look at anything else. And if I look at just those things, and modules will help me because where I have to be a good citizen and not do things in header files, modules will hold my hand and make sure that I don't do some awful things, which we'll discuss later, some very awful things. The modules won't let you do that. And that's not an accident. That is actually, after long arguments with people, there's certain things that the standards committee does where they try to tell you it's not good for you, don't do it. And people say, wait, I need to do that. But it's really not, and eventually we say live and let live, and we say if you want to do it, do it. I don't think it's a good idea, whatever. But then there are some things like polio where you say, no, we're just not going to do that. We really aren't. And there are two things that modules do, three things actually. Two of them are like polio and one of them is close. So there are three things that modules do that are awesome, that stop you from making the classic mistakes that people have made throughout history. So that's where modules come in really handy. And they do something, I mean, you can guard against certain things, but some things just happen by accident, and modules will help us in those cases. We'll talk about that. So anyway, what we're saying here is if you use something substantively, not just its name, if you use it substantively, pound included. Okay, so we're going to talk about logical relationships just because that's an important thing to know about. I put this stuff up. This is sort of a classical thing. We don't really have value types that have inheritance. We don't do that, but this is a good illustration. So we have this notion of is-a, and so intuitively, a polygon is a shape, and you can see that I have this capsule-to-capsule relationship. These are logical relationships. I have uses in the interface, and a polygon would typically use what? Point in its interface, say to add a vertex. So we have this notation. And it turns out that a point list and a point list link, both of them will have the name point in the interface of one of their functions. By the way, a function uses a type in its interface if it names it as part of its signature or part of its return type. And a class uses a type in its interface if it has a member function that uses the type in its interface. So that's what we're talking about here. So Polygon has a member function at vertex, and so Polygon uses point. And point list, obviously, you can append a point to a list. Again, this is a toy example. We wouldn't do lists. We didn't do it this way, but again, we're trying to teach the notation, so this is useful. Now, if something is not programmatically accessible, but it's still used, let's say it has a or holds a something, then we say it's used in the implementation. We use a solid black bubble. So a polygon might have a point list sitting as a data member that you can't get hold of. You can't see it. You don't know it's there. So the point list is an implementation detail of Polygon. Actually, I overstated. The Polygon, the point list, the use of the point list is an implementation detail of Polygon. I might change it to a vector later, but right now it's a point list and no one knows programmatically, but you can look at the code and see that. So anyway, it's used in the implementation. Point list happened to use point list link in its implementation, but that's not a big deal because it's in the same component, so it has no physical implications. Anyway, and then we have this funny thing that people have a lot of trouble understanding, which is uses in name only. And it turns out that a shape uses point in name only because nowhere in the shape component, not in the CPP, not in the H, because it's abstract, nowhere in that component does it include point. And still we can have the shape component. So this is surprising to people, but yes, in fact, shape does not need to do that. Yes, sir?
That depends on the API.
Depends on...
If I say each shape has the center and the center is a point?
And no, but this is an abstract type. Shape is abstract.
Yeah, so abstract types can have members, why not?
It's a pure abstract type. It doesn't have any members. All it has is a non-pure virtual destructor, and every single function, including getOrigin, is a pure virtual function. And therefore, it doesn't need to. By the way, let me be clear. It's not just an abstract. I'm making certain assumptions. For example, I would never design a protocol, a hierarchy like this, where the base thing is anything but a pure abstract interface. I call it a protocol. But I just assume that. People do create structural inheritance things and use them in strange ways that I just hurts my head, so I don't even think about them. But yes, you could design something that's kind of broken, and then certain things would be true. But in this particular case, where we have a pure abstract interface, where all we have is a destructor that's declared empty and out of line for reasons we can leave out of this, and every other function is a pure virtual function, which we'll see, life is good. Are we good? No. What's the problem? So suppose the pure abstract function returns point by value. Do I need to include it? Think about it. We'll get there. All right. So anyway, what I'm saying is there is no physical implication. It's only a collaborative one, it'll turn out. Then there's this thing called depends on. Depends on is totally different. It's between modules. It's not between types. So here, the Polygon module, notice I'm cheating, I'm reusing this slide, calling it something else, a little bait and switch. Polygon module depends on the shape module because inheritance is a very strong logical relationship that has the implication of dependency. Polygon uses point in its interface, and that too has a very strong implication. Same with pointless for the same reason. And pointless link also. And both of those are in the same direction. They have the same implication. And then finally, uses in the implementation has that implication. These are called implied dependencies. If something uses something in the implementation substantively, you will need to include it. What's interesting is that's not true of shape and point. So that's why we have this dotted line. There is no implied dependency. And so when we use a dotted line, we're saying there's a collaborative dependency, but it's not a physical one. All right, level numbers. If you just look at this picture, you know you can assign level numbers. It should be fairly intuitive. I'm going to start us out. Things that don't depend on anything else are at level 1. What level is shape at?
1.
Correct. Shape is at level 1. What's at level 2? What's at level 3? Okay, that's all you need to know. That's level numbers. Moving right along. Essential physical design rules, there are 2. Does anybody know what the 2 module-enforced design rules are? And there's a third, but these are the 2 big ones, big ticket. What do we not like? If you've ever read my book, what is it I hate? What kind of dependencies? Cyclic dependencies. There are 2. One of them is no cyclic physical dependencies. We don't do that because that hurts our head. What's the other one? Chapter 3 in Lakos 96 at the end? No? Long distance friendships. So it's interesting, there are these guys, maybe you've heard of them, Dijkstra and Parnas. Little did we know that Dijkstra was really big on no cyclic physical dependencies, and Parnas was really big on no long distance friendship. And I didn't know that when I wrote the first book until I did my PhD dissertation a year afterwards and found out, oh, these guys knew that too. Awesome. So these are the 2 big rules. So let's not do that. Then we like to have fine-grained reusable modules. Fine-grained reusable modules. So we'd like to put, if we can, to the extent that we can, 1 primary class and associated free operators in that module, also known as a component. So there are 4 reasons to co-locate logical content classes, public classes. We can have private classes. There are reasons to do that. But that's not important. That's an empty detail because they're private. They're part of the module. And modules, thank goodness, allow us to have a private section so we don't need to irritate people by saying, I have a convention, this class has an underscore, which I forgot to mention. The underscore means it's private. But now in modules, you can make it private. You can make it really private. Even though it's used in the implementation, it can still be private. So that's a great thing. But there are 4 reasons to co-locate public classes in a module. Can anybody think of what those 4 reasons might be? Any one of them. Why might you do it? There's a number 1 reason, like Family Feud. There's one reason that's the number 1 answer. What is it? Inheritance? Actually, that would be a reason not to do it, right? Because I have a base class, and now I want to have an open system, and I don't want to couple my derived class with my base class. I want to be able to hand my base class to my client, and then I want to be able to create new derived classes. So no, not inheritance.
Refer to each other?
What?
If they refer to each other?
If they refer to each other. So if they would cause a cyclic dependency. Okay, that is reason number 2, but that's very rare. And in our methodology, we would try not to let that happen even within a single component because it's hard to think about. We do it only if it's necessary, for example, recursive templates. Anybody? What's the number 1 reason?
All of your public interfaces in one place only, so I have to look up only one place to see what the module does.
Okay, well that would be a reason, what was just said is we want to have a facade where we go and look at something, but that facade or wrapper is up here, but I'm talking about the subsystem that it controls. So why would I put 2 classes in the same component? That's the question. Why would I do that? All right, here's a hint. Suppose I had a container and its iterator, and I wouldn't nest them, and there are reasons for that, but leave that alone. So I have the iterator and the container. Why would I put them in the same component? It's not that one can't be used without the other. That's not the reason. Okay, the number 1 reason is friendship. If I need private access, and in the case of iterators, I need private access because the whole point is to allow the open-close principle to be realized, right? Iterators allow me to do things. I can write code using iterators. I don't have to go in and add a method. I can iterate over the elements. The iterators have private access. If I change the implementation, the iterator changes. They're together. They have private access. So friendship is the number 1 answer. If there would be a cyclic dependency, that's the second answer, but that doesn't happen. You shouldn't be doing that. Unless it's provably necessary, which is recursive templates, there's no reason to do that. So don't do that. The third reason, which has gone away mostly for C++, is what I'll call single solution. So if I don't have variadic templates or macros, and I need to create a whole bunch of like things that together solve a single problem, but don't actually depend on each other, they're collaborative, that they look like this, then that's okay. But don't get confused with this. Here's a situation where I have, for example, a point, and then I have a coordinate, and then I have a point, and then I have a box, and then I have a box collection, and then I have a garage. And you can see that at each level going up, I have more things going on. That's not a reason to put something in the same component. You might argue, well, how can I use a box collection without a box? That's silly. Of course I'm going to put the box in the same component as the box collection, or same module. And the answer is no, that's not silly, because I may be able to use a box and not need a collection of them. Certainly I don't need a garage, certainly not. So I'm going to put all of them in different components. That's a bad idea, this is a good idea, and now I can use the coordinate, the coordinate point and box, the coordinate point, box, and box collection independently of the garage. And that's fine-grained hierarchical reuse, and that's good. This is fine. Do you see the distinction? So I have a bunch of templates together that solve a problem. They don't depend on each other. One component, single solution. I have a bunch of things that depend on each other as I go up the line. Different components, and I don't care. Now, there is an exception, and that exception is called flea on an elephant. So, if you are a flea, and an example of a flea would be a tiny little class or a tiny little operator like operator double equals that doesn't need private access, it's just a little thing. I could put it in a separate component, but anybody using this thing would need it, and in fact the usage example for the module would want it. Instead of having to synthesize one and say, posit a guard that initializes this logger. No, here it is. It's a little piece of sugar. That's fine. We're not talking about nonsense. What we're talking about is the other way around, where I have a point and I have a graphical engine. The point is the flea, and the graphical engine is, oh my goodness. And to put them in the same component is nuts. Now, the idea here is don't do that, and don't have a slippery slope where you say, no, it really has to be a flea and an elephant, and it can't be anything else. It can't be a goat and a pig or a dog and a cat. No, it has to be a flea, honest to goodness flea, and an elephant. All right. Now we're going to talk about another aspect of physical design that you may or may not care about. Encapsulation versus insulation. Does anybody want to venture a guess at what those things mean, or why they're different, or how? What is encapsulation? What do I mean when I say something is encapsulated? What does it mean? What? Class or namespace. What is it? If I say you're encapsulated, what are you? Are you a class or a namespace? Something's in there. Okay. So what does it mean to encapsulate something? What does that achieve? Yes? Contain, good. Isolate, I like that. What?
Hide details.
Okay, so hide. So here, contain and hide. Originally, encapsulate just meant contain. So if I encapsulate the methods of a class within an object, I didn't say anything about hiding its data, but it came to mean that. So encapsulation tends to include hiding private data. That's what encapsulation means. But what do we mean by hide? Hide it how? How am I hiding it? Can the client's compiler see my stuff? If I have a point and it has int x, int y, can the client's compiler see my private data? Absolutely, because the client can use my point class to build a box. And in order for the client's compiler to make sense of it, it needs to know how big it is, right? So that's necessary stuff. Okay, so that's encapsulation, but then there's insulation. What's insulation? How is that different from encapsulation? The compiler doesn't see it. Okay. So let's look at some definitions. An implementation detail of a component type, data, or function that can be altered, added, or removed without forcing clients to rework their code is said to be encapsulated. Compare that with an implementation detail of a component type, data, or function that can be altered, added, or removed without forcing clients to recompile is said to be insulated. All right, now I'm going to ask the hard question for the people who really know their stuff. You ready? How many people think modules will help us with insulating our implementation details? Yes. You do think so? Can you please inform me how that will happen? Because I have no idea. Will it do one blessed thing to help you with insulation? So this gentleman, I need to buy you a drink. Because the point of modules is to solve all problems, including world hunger. You don't need to test them. They insulate everything, so they cause no problems whatsoever, and all the code that you write is perfect. Okay, so it turns out that modules aren't quite that good yet, and in fact do absolutely nothing for insulation purposes, just to be clear. We'll talk about that more. Anyway, let me explain what I mean by insulation. I have some components here, A, B, C, D, and E. Okay, so now let's say that A is the client. Okay, let's say that C is a library component. Let's say that D is an implementation detail. If I make a change to the header of D, or if I make a change to the public part, the interface of the module, if you prefer, the thing that gets imported, if I make a change to that, what happens? Well, it turns out that imports to here, which imports to here, and this guy will have to recompile. In other words, if the public part of the thing that I'm doing, the thing that I'm exporting, which is what header files do, if that is propagated to the client, if that's necessary for the client to do its job, and you change it, then the client's going to have to recompile. That's just the way life is.
No, but then it's not really an implementation detail.
Okay, so hold on. That's interesting. It's not an implementation detail if you change it to do something else.
Well, I mean, it's included in the header, so it's pretty much part of the public interface.
But well, it's included in the header, but then is the body of an inline function an implementation detail or not? So my definition of implementation detail is that it's not programmatically accessible, and if I change it and I don't change the contract, life should be good. If I change the contract, if I change the behavior, it's over. If I change the signature, might be over, right? But if I don't change the contract or the signature, and so it does the same thing, then I call it an imp detail, even if the client has to recompile. Yeah? Okay. All right. So D is encapsulated by C. Now this is a shorthand. That's not really true. Anybody can use D, right, Andre? Anybody can use D, but they can't know that they can't know that C is using D necessarily. So the use of D, did I get that right? The use of D is encapsulated by C. D is still available to be reused hierarchically. You can use it somewhere else. But the fact that I changed it, okay. Now I've got this thing, this imp detail E. Now E is a little different. It's used from the .cpp file or the module implementation part. Here, if I change this, yes, C has to recompile, but the part that's exported to A doesn't change, so the use of E is in fact insulated. Now, if I take E, throw it out, and write something completely different, E is still available for reuse elsewhere. That's great. And none of my clients have to do anything but relink. Okay? Good. So criteria for having to pound include in a .h. Nico, I'm going to address your question now, just so you know. A header file must be self-sufficient with respect to compilation. There are 5 major reasons for including a header in a header. ISA is the first one. That's the strongest one. If I ISA that, you don't even need to pound include that directly. Just know that because I am that, I'm inherently that must come along for the ride. So the one place where you don't have to include what you use, if you use a derived class, you don't need to separately include its base class. But nothing else is strong enough. So just using something else, even in the interface, you still want to include it. The rule is if you include it, if you use it, include it. Don't rely on something else to include it. Now, if something else uses something in the implementation and you rely on that, you could get hosed, right? Because they change their implementation, they take it out, you were counting on that header file, that's called a transitive include. Guess what? Modules fix that. Modules, if you've got something that your object uses in its implementation, the client compiler can still know about it without allowing clients to be able to create new ones of it. So modules got that part right. That's really great. The transitive includes of headers is solved. So ISA is one. HASA. HASA means I've got an object embedded in my thing. That's a strong relationship. What's another one that I would have to pound include? I'm waiting. Somebody's going to say it.
Uses?
There you go. Not uses.
In a new line, for example.
Okay, we'll get to that. Let's leave, but uses alone is not enough. So for example, point, append, right? See this example here? I'm using point by reference. Well, that I certainly don't need to, right? Because I can just say class point and I'm good in the header file. But here's the part that you might not realize. See how it returns point by value? Turns out that I don't need to pound include it even there. Unless the client needs to know the definition of point, I can simply say class point. A lot of people don't know this, but it is in fact true. So this is, I think, in response to Nico's question, only if the client needs it, or, as was pointed out, inline functions. If it's used in the body of an inline function, absolutely. And by inline function, you get the idea. And then enumerations. Enumerations in C++03, you have to do this. Now, yes, in C++11, there are ways to forward declare them. They are absolutely evil, absolutely as bad as forward declaring an int. Do not do that. I could explain why, but I'll spare you. And the fifth one is, if you have like std string, that's not really an std string. You can't really forward declare that. You really have to pound include at least the forwarding. Yes?
What about nested classes? You can't forward declare them.
Okay, so long time ago, in a place far, far away, nested classes didn't work. Finally, people beat on them enough that you can actually make nested classes kind of sort of work. But to save you any further discussion, we do not use nested classes. What we use instead are classes that are private to the component so that you don't get that problem of some sort of weird, friendship cycle. It's all backwards and goofy. And I don't understand it except well enough to write about it once to say don't do it. And then I forgot about it because no one needs that. What they need is to create whatever you need here, get your head around that, then have this thing depend on that inside the same module and make that private. Now that we have modules, we don't need to have this telescoping down into this micro thing. By the way, have you ever seen something that has public and private layered in it? This is public, private, but nested. It's unreadable. Don't even. If you have a struct that has two things in it and no methods, maybe nested. That's the limit, okay? So there are other things like covariant return types and edge cases, but don't worry about it. These are the 5 reasons. So are there any questions on this? Yes?
Is there any tool help?
Is there any tool help? We have something called BD Verify that we've been working on forever. It's Clang based. And what it does is it basically looks at what you have and just says no, 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 no. And it does a lot of good stuff too. It rewrites it so that it can be yes. Yes, 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 yes. So we have actually that too. This is many, many, many years in development by a really senior developer who really likes to write these kinds of things. I mean, that's his job, is to write these crazy analysis and refactoring things. You know, it's like Google does it, Bloomberg does it, and it's awesome. And it's part of our development process, because why would you make somebody review your code if it doesn't compile? So why would you make them review your code if it's wrong? No, we don't. So yes, there's tool support. So here's some questions you might want to ask. We have only like 13 minutes left, and I have another part, so I'm going to try to go a little bit quickly. By the way, I might go over by 5 minutes. I'm just saying. I hope I don't go over by more than that, but if anybody needs to leave and get a break, I'll try not to go over too much. Any other questions? How do we extract component dependencies efficiently? What is the rule? What is the thing that allows us to do that? So if we use something where a dependency is needed, where there's an actual dependency, we don't forward declare it, we pound include it. Then we can look at the envelope of includes or imports and instantly, without clang, and we've been doing this for 30 years, instantly know what the dependency graph is. When would I put an include directive in a header file? What are the reasons? ISA, HASA, inline, enum, and typedef to template. And you're not supposed to forward declare standard stuff anyway. What benefit is generally associated with installation? Why do I like installation, and why am I really sad that modules will give us none of it? Do I want modules to give us installation? Would that be nice? The answer is no. I don't want modules to give us installation because installation implies slowness. It means that I'm putting overhead to separate myself from something else, which means an extra level of indirection, memory allocation, all kinds of stuff I don't want. Modules give you none of that, so modules provide no performance cost. That's good, but if you have that, then you don't have installation. And that's the way life is. You can't have it all.
Do you mean compile time or runtime performance cost?
There's no runtime performance cost because of modules. To be determined, right?
Okay.
Do you agree? What is your comment? Do modules help or hurt compile time?
We will find out.
We will find out. Nico has said. Nico has spoken. All right. So we have to get to the second part. I'm just going to quickly summarize my paper, what I'm hoping for, because modules are what they are as a result, to some extent, of pushes in this direction. So this is the paper. I'm putting the paper up here, and the blue stuff is what I'm going to talk about. It's a critically needed language feature. What we're really looking for, I'm looking for, is something architectural. It was originally motivated for performance. The performance will come, but we need to get the architecture right. That's basically what this is saying. The purpose of this paper is to focus on what features we need to have modules provide. You just saw components, those slides. If modules are not an absolute plug-in substitute for what I just talked about, I will not use them. Fortunately, I think they are. Okay. So, tooling is an issue. That's my biggest concern. But this talk is not about what I'm concerned about. Premature optimization is definitely something I was concerned about. And I think what we've got now is we've got the architecture right enough, not complete, but right enough that it's going to give us those things that we need. So some of the properties that we want are, we want to make the introduction of modules possible. So at CPBCon a couple of years ago, after someone explained what modules are, I said, hi, my name is John Lakos, I'm from Bloomberg. I want to use modules. Could you tell me what is the migration path for modules? You can go look at this on YouTube. It was right after the talk, and he said, well, wait. Let me just ask you, is it possible for you to change all of your code and all of your client's code to modules at one time? I had no words. I said, I wish there were a stronger word for this, but no. and he said, well, then you're over-constrained. I was speechless, and I still am. I don't know what to tell you. Anyway, we need to make sure that people can adopt modules in an additive way, in an incremental way, in a hierarchical way, and in an interoperable way. So what do I mean by that? So if some group at my company wants to start using modules, let them. As long as nobody is depending on them who doesn't have access to a C++20 compiler, life is good, right? They do what they want. We don't care. But as an infrastructure group, if I start using modules and I say, I'm sorry, we just took away all your header files, I mean, being fired would be the least of my worries, you know? I mean, that's not going to happen. So the next thing is, if some group is using modules and some other group is still using header files, and now some new group comes along that is module aware, are these guys interoperable? Can I use both in the same program? Well, that had better be true, right? If I add a module here, if I do something here, it better not affect the code down here. This code better do the same stuff. You could imagine some weird world in which this thing stuffs something down here that changes this behavior. Well, that can't happen. So everything that was is. Everything that's added is additive. It can be done in independent places. And then finally, and this is the critical part, if I have a date class down here, and I have a module that exports that date class, and I have a header file that exports that date class, and then I have a client that consumes that date class, it had better be the same date class, and it better not be an ODR violation. That better be true, right? Otherwise, guess what? Okay, that doesn't seem like too much to ask, so I asked it, and I believe it was satisfied. There was somebody in my company where I basically said, here's the paper, here's the world, make the world look like this paper good. Thank you, go. And he did. I mean, he did his job. He's a good kid. Not a big task. Anyway, so logical versus physical encapsulation. That's one of the things that modules do really well. Logical encapsulation, whereas header files, we were able to simulate what we want. We had to be very careful and write tools and whatever. Modules actually satisfy that by not allowing access to things that are not explicitly exported. So if I have a box and a point, and my point class is an int_detail of my box has 2 points. And I ship that out to clients. Clients are free to use my box, and they can go ahead and make a box collection, and they can go ahead and make a garage and do all that good stuff. And if later I come in and I take point out of the box and put in 4 ints, none of my clients will have to rework their code because they never had access to a point to begin with. That's fine. They will have to recompile, though. Is that clear? They won't have to rework their code due to transitive imports, but they will have to recompile. So that's one of the things that we wanted to have. Here's something that I want to have. This is a particular clause in the thing that we don't have. I would like, when I have this client over here using modules and this client over here using modules, I want them to provide different views on my subsystem. So here's my subsystem. It has lots of classes and da-da-da. And here is a module that provides a facade with a subset in the inverse Liskov sense, a subset of the functionality that this stuff has. So it's a view on what you can do here. So imagine you have a stack class, and this view gives you push, and this view gives you pop. Imagine a client up here that includes both definitions, both views of stack. They get united into the union of capabilities. So what this is like doing, in some sense, this is like hiding header files on a per function basis to give you a view of a subsystem. But the reason we want this is to try to do this in code by creating a wrapper or whatever. It has 2 problems. 1, it's extremely costly and time-consuming and clunky. And 2, the vocabulary. If I try to wrap a date with my date, I have the multi-component wrapper problem where now I want to take this date and put it in that thing, but I've got 2 things here, so I have to look inside, and that's long-distance friendship, and that's no good. What we can get away with here is if we provide a view on something, the thing that you have is a handle to, it's actually a handle to the thing. Much in the same way that a procedural interface which is also talked about in the paper, which is clause D. A procedural interface, when you get back an opaque pointer in C to a C++ object, it really is that object. And if somebody were to toss you the header file and change your compiler to C++, that pointer that you got back, you could just use it in C++. We want those same properties to hold at the, not at the installation level, but in the encapsulation level for modules. So that's a goal. So that's what part D is here. Now, if you go read this paper, it's literally 3 pages in ASCII. I typed it in one evening. It's just off the top of my head. But it's kind of a good paper because it kind of set the tone. So given that we have only a few minutes left, I'm going to just quickly run through this. Here I have a basic system written in header files. This is my library system. And I have a client, some system, has header files, and then I have a module system. That's that little diagram at the bottom. And now I add a new module system that depends on the old one. And now let's say I have a client that uses both the new module system and the old header system. This has to work. That's what I'm saying. Then the next requirement, this is the thing I was talking about. This is the part where they have to be the same type. So, again, the procedural interface concept. Google was doing something about a year ago. I admit I haven't kept up with what they're doing, so anything that I would say here is out of date, so I'm going to skip that. Once we've addressed all 3 of these important issues, all of the other requirements, then we can focus on performance. And I think performance is very important, but it's something that comes after. It's like the big rocks, get the big rocks right, and then the little rocks, and then the sand, and then the water. I would say the performance is more in the sand and water area, not in the big rock and little rock area. So there are many different reasons for dealing with, for having modules. They're competing ideas and whatever, but they have to solve certain business requirements or they're not going to be useful. Particularly large legacy code bases exist. And so I'm putting up this chart just basically for people to look at, and here are the 4 requirements that I had. And we want to fix the transitive include problem. That's a big deal. We want to make sure that in modules, we have the ability, when we set a contract assertion level, that it comes with the module, so that it's not that the entire program has to be set at one contract assertion level. This module could be set higher or lower. And ultimately, contracts are still under investigation because we want to make sure we give them proper granularity. And now that modules are out, we can look at the contracts in terms of what modules might afford. So that's also a slight benefit. I want to be, as I said, in the future, not for C++ 20, but for C++ 23 or 26, I'd like modules to be able to provide fine-grained views so that we don't have to do these crazy sort of perturbations of things, and then we get the union of the capability. So again, just a quick picture. I start out with what I have today, which is libraries and clients and header files. Then I add some modules. I add some more modules. I add a client that uses modules. He or she wants to use this header file, that's no problem. Or originally, I want to use the base directly, that's fine. Then I get this other client that wants to use his modules. Then this guy can point to that guy instead, that's a replacement, or not, it doesn't matter. Then client 2 could come along and use the module 1, and all of this stuff has to work together, and it has to be able to be built up over time seamlessly, right? It can't be, oh my goodness, let's recompile the world, because that's not a real thing. And then maybe eventually this client comes back over. All right, anyway, that's pretty much, we don't, this is just a repetition of what I said before. So I'll just put that up, and we are just about out of time. Do we have any questions? Yes?
What's the gap between it has to work this way and it's currently defined in the standard as working that way?
Oh, so in 2017, there was a huge pressure to get modules out the door. And what I said was, I'm not going to use them unless they at least do this for me. And it's not grandstanding. If they don't do this, I just can't use them. So they have to do this. So there was a lot of effort made to make them do this. So I think that modules do the basic functionality now that they need to. There's still a huge question about tooling. There's still a huge question about how do you discover where something is in a module. There may need to be a lot of convention built around how to use modules the way there is now with header files. That convention doesn't seem to exist yet. So what are the engineering requirements for modules? Whoops, did I just jump over that? I think I did, but we're out of time anyway, aren't we? Doesn't matter. This is good enough. So if there are any other questions, well, all right, well, yes?
Would you say that Java or C# has solved this problem?
Say again?
Would you say that Java or C# has solved this problem with modules?
I can't speak to Java or C# about modules. Modules are something about C++ where there's a huge effort to achieve encapsulation. So I don't know what Java does that would have anything like modules. Modules they're very, very specific to a .h.cpp pair, getting rid of very specific things. Plus, I'm not a Java or a C# expert. I wouldn't know. Anything else? All right, well, thank you for coming. There's another talk in 15 minutes.